far beyond the edge of our solar system, where sunlight fades into silence, something began to move. Not fast, not chaotic, but steady, as if the universe itself had found a heartbeat. Astronomers call it 3I Atlas, the third known interstellar object to ever visit our solar system. But unlike the others that came and went without pattern, this one does something different. It shifts, it pulses. Every few hours, it brightens and fades again, following a rhythm so precise that even seasoned scientists had to stop and whisper, "This isn't how comets behave." It began quietly. Two Russian astronomers, working through the chill of an October night, noticed a small irregularity, a comet's position changing in a way that shouldn't be possible. They checked their data once, twice, a dozen times. Each time, the pattern held. And with trembling hands, they published their results. A 4-hour shift, a 2-hour pulse, a cosmic heartbeat. That was all it took. Within hours, the message spread through observatories across the world. Russia had spoken. NASA said nothing. China said nothing. Europe, too, fell silent. And so the story began not with explosions or spectacle, but with silence. A silence that carried weight. A silence that made the whole world listen. There are moments in human history when discovery doesn't just answer a question, it changes the kind of questions we're able to ask. Moments when the universe stops being a backdrop and starts feeling like a conversation. 3I Atlas might be one of those moments. Because if this data is true, if something out there really is pulsing with machine-like precision, then the universe we thought we understood messy, random, chaotic, might not be as empty as it seems. But before we rush to conclusions, before we whisper aliens or miracles, we need to slow down, to look carefully, to ask what the evidence truly says and what our hearts want it to say. In this story, we'll walk step by step through the mystery of 3I Atlas. We'll explore how two lines of light on a computer screen ignited one of the most profound scientific debates of our time. We'll listen to the silence between nations, to the numbers that refuse to behave, and to the questions that keep scientists awake at night. We'll talk about the mathematics behind its pulse, the chemistry that shouldn't exist, the stability that defies time. And we'll ask quietly, carefully, what it would mean if this rhythm isn't nature's accident but someone's design. And yet, beyond all the science, there's something even more human here. It's wonder, it's curiosity. It's that same feeling that made us build telescopes in the first place, the quiet hunger to know if we're truly alone. From the first caveman who looked up at the stars, to the engineers sending spacecraft to Mars, that question has followed us like a shadow. Is anyone out there? And if they are, would we even recognize them? 3I Atlas doesn't answer that question. It doesn't wave or speak or blink a message in Morse code. It simply turns perfectly, rhythmically across the dark sea of space. And maybe, just maybe, that's its way of saying, I am here. So tonight, as we step into this story together, I invite you to do what scientists and dreamers have always done to keep an open mind, to balance skepticism with wonder. Because in the search for truth, both are necessary. We'll trace the journey of 3I Atlas from its first detection to the heart of the debate dividing the scientific world. We'll explore how physics and faith sometimes dance on the same line. We'll hear from skeptics, believers, and those who simply stand in awe. And in the end, we might not leave with certainty, but we will leave with perspective, a deeper understanding of how small we are and how extraordinary it is that we can even ask these questions at all. As you listen, remember this: the universe doesn't owe us explanations. It offers patterns. It offers silence. And once in a while, if we're paying attention, it offers something that feels alive. This is that moment. This that is 3i Atlas. A silent traveler from the dark between the stars, turning with the precision of a mind we don't yet understand. Stay with me. Because by the time we reach the end of this story, you may never look at the night sky the same way again. Part 1. Russia breaks the silence. The politics of discovery. When the first data about 3i Atlas was released, it didn't come from NASA. It didn't come from the European Space Agency or from the Chinese National Observatory. It came from Russia. That single fact changed the tone of the entire conversation. Because in the modern age of science, who speaks first often shapes what the world chooses to believe. At 3:17 a.m. Moscow time, 2 astronomers from the Keldysh Institute uploaded their findings to the Astronomers' Telegram, a global database where scientists quietly share sudden, urgent discoveries. In a few lines of technical language, they described a comet that wasn't behaving like a comet at all. Its brightness pulsed, its coordinates drifted rhythmically, and its behavior didn't match any existing model. The words were cautious, clinical, yet between those lines, you could feel something else. Excitement, fear, the subtle thrill of being the first to whisper, "We found something." Within hours, the notice spread through private astronomy forums, university research groups, and small observatories from Arizona to Kyoto. By sunrise, every scientist with access to a telescope was pointing it toward the coordinates listed in that Russian report. And then, silence. NASA made no comment. The European Space Agency paused its public updates. China's official channels went quiet. Only Russia kept speaking, updating their data, refining their claims, giving the story a pulse of its own. For many, it felt familiar. Because this wasn't the first time discovery had collided with politics. In 1957, when Sputnik first crossed the sky, the world didn't just see a beeping metal sphere, they saw power. In the Cold War, even a satellite became a message. We were first. And with that one act, Russia didn't just change technology, it changed history. The United States, startled by that tiny glint of light, launched what would become the greatest scientific race of the 20th century. Now, almost 70 years later, something similar was happening again. But this time, the battlefield wasn't in orbit. It was in data, in who owned the story of a comet, or maybe something that wasn't a comet at all. Inside NASA, according to reports leaked days later, discussions grew tense. Before any public statement could be made, the data had to be verified. The object was faint, fast-moving, and extremely far. Every analysis took time, and in science, time is everything. But in the digital age, patience feels like silence, and silence quickly becomes suspicion. When Russia continued to post updates, American journalists began to ask uncomfortable questions. Why weren't other nations confirming? Was the data being withheld? Or was it simply too strange to be believed? The truth was simpler, and perhaps more human. No one wanted to be wrong. Not after Oumuamua, not after years of debates that had turned science into spectacle. Sometimes, the hardest thing in discovery isn't seeing the unknown. It's admitting that someone else saw it first. Yet amid the tension, there was also something deeply poetic. For once, in a fractured world, people from every nation were looking at the same patch of sky, the same tiny moving light, billions of miles away. No borders, no politics, just shared wonder. In small observatories in Chile, Japan, France, and New Mexico, young astronomers watched the same flickering point and wrote in their notebooks the same words. It's still pulsing. But as the story unfolded, another layer began to reveal itself, one not about astronomy, but about humanity. Throughout history, every great discovery has had two sides: the light of truth and the shadow of control. Galileo's telescope, Darwin's notebook, even Einstein's equations each brought clarity, but also controversy. Because knowledge is power. And power always asks the same question: who gets to tell the story? For Russia, publishing first meant leadership. For NASA, caution meant credibility. For the rest of us, caught in between, it meant confusion and fascination. We were reminded once again that science doesn't exist in a vacuum. It lives in people, imperfect, emotional, ambitious people. And sometimes those human stories matter just as much as the data itself. One American astronomer later put it beautifully in a podcast interview. He said, maybe the real signal wasn't out there in space. Maybe it was right here in how we react when the unknown knocks on our door. That sentence lingered with me, because when you think about it, every great mystery reveals not just what's out there, but who we are when we face it. Do we unite to understand? Or divide to claim credit? Do we whisper or listen? Do we let wonder lead or fear? That, perhaps, is the real heartbeat behind 3i. Atlas not in the light itself, but in our response to it. And yet, beyond the noise of news headlines and institutional rivalry, the comet, or whatever it truly is, just keeps moving, unaffected, unbothered, silent. While we argue about who saw it first, it continues its rhythm through the dark. A perfect 4-hour spin, a perfect 2-hour pulse, indifferent to borders, indifferent to pride, just doing what it has always done, turning in time to a song we have only just begun to hear. Sometimes the universe doesn't care who claims discovery. It only rewards those humble enough to notice. And maybe that's the quiet lesson of 3i Atlas, that in the vastness of space, ownership means nothing. Awareness means everything. As the weeks passed, the silence began to crack. Observatories in Europe and South America confirmed the same strange pulse. And suddenly, what had been a whisper in Russia became a global conversation. Scientists no longer asked if it was real, but why it was happening. And that's where our story turns next. Because behind that rhythm lies a pattern so impossible, so precise, that it forces us to ask whether nature alone could be keeping time. Part 2. The pattern of the impossible, when chaos finds a rhythm. Every comet ever known has danced to chaos. Their rotations wobble, their paths twist, their brightness flickers with the unpredictability of wind and flame. That's what makes them so beautiful. They're messy, alive, imperfect, until now. Because 3. Atlas somehow refuses to behave like the rest. When scientists plotted its brightness over time, they expected the usual noise, the messy heartbeat of dust and gas streaming into space. But instead, they saw something that made them stop and check their screens twice. A rhythm, 4 hours, a subtle change in its trajectory, 2 hours, a precise pulse of light, then again and again, like clockwork, perfectly repeating for days, weeks, months. In the language of science, it was called a dual harmonic signature. But in simpler words, it was a song. A song the universe wasn't supposed to be able to play on its own. Imagine you're standing at the edge of the ocean. Waves crash at random, unpredictable. But suddenly, among the chaos, one wave hits the shore every exact 2 seconds for hours. At first you might think it's chance, but as it keeps happening, you begin to wonder, is someone timing the sea? That's what astronomers felt looking at the 3I Atlas data, a mix of awe and unease. Because the cosmos isn't supposed to keep perfect time. Nature makes rhythm, yes, the beating of a heart, the orbit of a moon, but never this exact, never this controlled. To make such precision, something would have to stabilize it, like a gyroscope or a design. Of course, scientists didn't rush to that conclusion. They did what scientists always do. They tested, they searched for natural explanations, dozens of them. Maybe the pulse came from dust jets bursting rhythmically as the object spun. Maybe it was sunlight reflecting off a flat surface. Maybe the data itself was flawed, an illusion created by the timing of telescopes. But the more they searched, the stranger it became. The rhythm stayed. No matter who observed, which instrument was used, or from what angle, the same dual beat appeared, like a breath that never skipped. To understand how rare that is, we can look at Comet 67P, the one visited by the Rosetta spacecraft in 2014. It tumbled like a drunk dancer, spinning every 12.4 hours, its brightness changing unpredictably. Even with direct measurements from orbit, scientists could barely model its motion. It was that chaotic. Or Halley's Comet, famous and ancient. Its rotation period wobbles by hours every time it swings around the sun. No two passes are the same. But 3I Atlas, 4 hours, 2 hours, perfect for nearly a year. That's not just unusual, it's statistically impossible. Some called it a coincidence. Others whispered the unspoken word, artificial. But beyond the theories, beyond the arguments, something deeper was happening. Something human. We, as a species, have always looked for patterns. It's how we make sense of the world. From the first footprints in sand to the first constellations drawn in the sky, we search for rhythm in the noise. We find comfort in repetition, in the idea that there's order in the chaos. Maybe that's why this discovery hit so hard. Because in 3I Atlas, we weren't just seeing a pattern, we were seeing ourselves, the need to believe that even the universe has purpose. One astronomer from Chile described it beautifully during an interview. He said, "It's not the numbers that move me. It's the fact that, for once, the cosmos feels like it's keeping a promise." That sentence lingered across the community. A promise that behind the randomness, there might be intention. Not necessarily from another civilization, but from nature itself. Reminding us that perfection can still exist in the wildest places. So what could cause such precision? A few models suggest an internal gyroscopic core, something heavy, metallic, spinning beneath layers of dust and ice. Others propose synchronized outgassing, small vents releasing vapor in timed intervals. But to maintain that rhythm for months, through temperature changes and solar tides, would require engineering-level stability. Still, no one has proof, only data. And data, as every scientist knows, can both reveal and deceive. Yet even without proof, the image is powerful. Out there in the silent dark, a lonely traveler spins like a perfectly wound clock, ticking through eternity. A mechanical serenity inside cosmic chaos. And whether by nature's accident or by someone's design, it's breathtaking. Because it reminds us that even the coldest corners of space can still hold elegance. And maybe, just maybe, intention. In life, as in the cosmos, patterns don't always mean control. Sometimes they're invitations, gentle reminders to look closer. When something repeats with perfect grace, it's not asking us to worship it, it's asking us to understand it. And understanding begins not with certainty, but with curiosity. As the days went on, scientists began layering new data over the old. The rhythm didn't fade. In fact, it seemed to strengthen, as if the object were responding to being observed. Of course, that's impossible. But then again, so is everything about it. And soon, the questions started shifting from what to why. Why this rhythm? Why now? Why out of the infinite possibilities of space would something travel into our system, keeping time like a metronome set by invisible hands? These were no longer questions of mechanics. They were questions of meaning. And that's where the story deepens. From observation to philosophy. From data to belief. Because when a pattern refuses to break, it starts to feel less like coincidence and more like communication. Part 3. Anatomy of a Ghost, the Science of Comets Rewritten. When you look at a comet through a telescope, you're not really seeing a rock. You're seeing a ghost, a fragile body of dust and frozen gas, shedding itself into light as it falls toward the sun. Each one is a time capsule, a memory of the early solar system, made of the same ingredients that once built planets, and maybe life. For centuries, we thought we understood these ghosts. We knew they spun unevenly. We knew their icy hearts cracked and hissed as heat reached them. We knew their trails, those long silver veils stretching across the night, were the visible size of an object slowly disappearing. And in that decay, there was beauty. Comets were the perfect metaphor for impermanence, fleeting, brilliant, doomed. But 3i Atlas changed that story, because this ghost doesn't behave like it's dying. It behaves like it's alive. Let's step back for a moment. How does a normal comet actually work? At its center lies a nucleus, often just a few kilometers wide. It's made of ice, water, carbon dioxide, ammonia, mixed with rock and organic dust. When sunlight warms the surface, the ice sublimates directly into gas, escaping through cracks and pores. That escaping gas carries dust with it, creating the comet's glowing head, the coma, and its long, shimmering tail. The problem is that outflow isn't even. It's random. Some areas vent more gas, others less. As the comet spins, Those uneven jets act like miniature rocket thrusters, pushing it unpredictably and making its rotation wobble. That's why almost every comet has an erratic spin, changing speed, tilting, twisting, a graceful chaos. So, when something out there keeps turning exactly every 4 hours without a single drift or hiccup, it breaks every rule we've ever written about how comets survive. In 2014, when the European Space Agency's Rosetta spacecraft arrived at Comet 67P Churyumov-Gerasimenko, it found a world that looked more like a crumbling mountain than an object of precision. The surface was jagged, fractured, scarred by thousands of eruptions. The comet was spinning irregularly, tumbling slightly, its rotation changing by minutes every few weeks. It even sang, a low electromagnetic hum, the song of the comet, caused by plasma waves rippling through its dusty atmosphere. Everything about it was wild and untamed, pure cosmic entropy. Halley's Comet was no better behaved. Every time it returns, its spin slows or speeds up depending on which side faces the sun. In some orbits, its tail even breaks apart. Astronomers joke that predicting Halley's exact rotation is like predicting the dance of smoke. Then there's Comet Wild 2, visited by NASA's Stardust mission. It had so many impact craters and gas vents that its trajectory was described as a chaos of tiny explosions. That's what we expect from comets. That's what nature does. But 3, Atlas doesn't explode, doesn't tumble, doesn't even flinch. It glides, as if balanced on a thread of invisible design. One researcher described it this way: it's like watching a candle flame that never flickers, even in the wind. And in space, the wind is everything: solar radiation, gravitational tides, cosmic dust. To remain that stable under so many forces seems unnatural. Not in the sense of alien, necessarily, but in the sense that nature rarely gifts us perfection without reason. Some scientists tried to explain it. Maybe 3Y, Atlas was made of denser material, metals or silicates, giving it more mass to resist external forces. Maybe it had a smooth, symmetrical shape, like a sphere or cylinder, reducing torque from uneven jets. But even then, the math didn't add up. Every model eventually decayed into chaos. No simulation could maintain the rhythm we see in the sky. So maybe the problem isn't the data. Maybe it's our definition of what a comet is. Because if comets are supposed to be random, and this one isn't, then either we've misunderstood the laws of their behavior, or we're looking at something that isn't a comet at all. When Galileo first turned his telescope toward the heavens, he expected simplicity, circles, orbits, or instead, he found moons spinning around Jupiter, sunspots crawling across the sun, craters on the moon. The universe kept refusing to behave. Now, 4 centuries later, it's doing it again. And perhaps that's the beauty of it, that the cosmos never lets us grow comfortable. It always saves one surprise for those willing to look closer. So what if 3I Atlas isn't a traditional comet? What if its nucleus isn't solid ice but hollow? What if the gases we see escaping aren't random vents, but controlled emissions, like exhaust from a slowing engine? These aren't answers, they're questions. But every great discovery begins with one that sounds a little ridiculous. Because before we can rewrite the rules, we first have to admit we've been reading the wrong book. In science, as in life, the most dangerous assumption is thinking we already understand. Certainty builds walls. Curiosity opens windows. 3I Atlas may not be the revelation itself, but it's a window large enough for wonder to walk through. And so, scientists began turning their eyes from its motion to its light. Because light, after all, never lies. It carries stories about what an object is made of, how it spins, even how it breathes. If motion could deceive us, maybe the answer was hidden in brightness. Maybe the truth was written not in its orbit, but in its glow. The next chapter of this mystery wouldn't come from mathematics, but from light itself. Part 4. The Dual Signature. When light speaks in harmonics. Every object in space has a rhythm. Some spin quickly, some slowly, but all of them, asteroids, moons, planets, dance to the music of light. They shine brighter, then dim, as they turn their faces toward and away from the sun. Astronomers call this the light curve, a kind of cosmic fingerprint. It tells us who they are, their shape, their speed, their mood. But 3I Atlas doesn't hum in a single tone, it sings in two. When scientists first mapped its brightness, they found not one repeating pattern, but two perfectly synchronized pulses. Every 4 hours, its position shifted slightly, a rotation, steady and calm, and every 2 hours a flash of light surged and faded, as if something on its surface were catching sunlight, deliberately. A dual rhythm, a harmony. To anyone else, it might have looked like noise. But to astrophysicists, it was a voice. The voice of an object that seemed to know exactly what it was doing. If you've ever stood beside a lighthouse on a foggy night, you know that feeling. The air is thick and still, the sea invisible. Then through the darkness, a single beam cuts across the water, slow, deliberate, timed. It disappears, then returns again. The same interval, over and over. To sailors, that flash means safety, orientation, design. Now imagine that same pattern, not on a coastline, but drifting between the stars. A light that turns, blinks, and repeats, not by accident, but by rhythm. That's what 3I Atlas looks like to some astronomers. Not just a comet reflecting sunlight, but a lighthouse in the cosmic sea. Of course, most scientists are careful with words. They don't say message. They say specular reflection, meaning sunlight bouncing off a smooth surface. Or periodic albedo variation, meaning something bright turning in and out of view. But underneath those terms lies a quiet wonder. What if this precision isn't random? What if we're watching something built, not born? To test that, researchers around the world began comparing the data. Telescopes in Hawaii, Chile, and South Africa measured the same two frequencies. The timing difference between the 4-hour spin and the 2-hour flash was exact, down to the minute. Even more intriguing, the ratio was 2.1, a simple, stable fraction. In music, that's the interval of an octave, the most natural harmony of all. One scientist in Prague joked that the comet was playing middle C, and while he meant it metaphorically, there was something almost musical about it, as though 3I Atlas wasn't spinning randomly, but performing. We've seen echoes of this before, though never quite like this. Satellites in Earth's orbit create similar signatures when their solar panels catch sunlight in rhythmic glints. Old rocket stages, drifting in space, sometimes blink as they tumble. Even the Voyager probes, launched nearly half a century ago, send back light that fluctuates with their spin. But there's a key difference. Those are human creations. They were designed to move in patterns. Nature's creations, by contrast, rarely hold rhythm for long. So, when something that looks natural acts mechanical, we pay attention because it blurs the line between geology and intention, between the made and the born. Still, the scientific community remains divided. Some argue that the flashes are due to anisotropic outgassing, tiny jets of gas escaping from vents on its surface in periodic bursts. Others think it's the result of a binary structure, perhaps two lobes rotating around each other like a slow waltz. And a few simply admit they don't know. But behind all the models, equations, and theories lies a quiet truth. The pattern doesn't fade, and the longer it holds, the harder it becomes to explain away. For the public, the fascination grew. Online forums filled with sketches, simulations, even music inspired by the heartbeat comet. Someone on Reddit called it the first interstellar metronome. Artists painted it as a silver spindle wrapped in light. And somewhere between art and analysis, the world began to feel connected again, not through fear or politics, but through wonder. A few months later, one scientist was interviewed for a documentary. When asked whether he thought it could be artificial, he smiled and said softly, "You know, maybe the better question is, if it were, would we even notice the difference? Because maybe the universe is old enough, wise enough, that its machines now look like mountains. Maybe the difference between nature and design is only one of patience. Sometimes truth doesn't arrive with noise or proof. It arrives with rhythm. Repetition is its language. If something in your life keeps returning again and again, maybe it's not coincidence. Maybe it's communication. Maybe, like the light of 3i Atlas, it's the universe quietly reminding you to pay attention. For scientists, attention is everything. So they began to study not just the timing, but the color of the flashes, the subtle change in hue between one pulse and the next. And what they found only deepened the mystery. The light wasn't pure white. It carried strange traces, a tint of cobalt, a whisper of green, faint hints of carbon, and nickel spectral lines. That wasn't supposed to happen. Typical comets glow gold or blue-white, depending on dust and gas composition. But this one's light looked manufactured, like something metallic beneath the frost. It was the first clue that 3i Atlas might not just be spinning, it might be speaking in chemistry. And so the focus shifted once again, from the pattern of its light to the elements that made it glow. Part 5. The chemistry of the stranger, CO2, nickel, and the knife-shaped rock. If you want to know the truth about a traveler, look not at how it moves, but at what it's made of. Because chemistry, unlike motion, doesn't lie. It carries memory. Every element, every molecule, every trace of dust tells a story of birth, of heat, of time. And when scientists turned their instruments toward 3i Atlas, that story began to sound unfamiliar. The first clues came from its spectral signature, the light it reflected back toward Earth. When that light was split into its rainbow of colors, astronomers expected to see the usual fingerprints of a comet. Water vapor, carbon monoxide, maybe a faint line of cyanide or ammonia. That's the chemical language of ice and sunlight, simple, ancient, predictable. But 3i Atlas spoke a different dialect. Its spectrum was dominated by carbon dioxide, far higher than any known comet of similar size. Even stranger, it released water vapor far earlier in its orbit than it should have, long before it was close enough to the sun to warm up. It was like watching frost melt in the middle of winter. Something wasn't adding up. To understand why this was so strange, we need to talk about how comets usually breathe. Most of them come alive when they reach what astronomers call the frost line, the point in their orbit where sunlight grows warm enough to sublimate ice. For most comets, that's around the distance of Jupiter. Before that, they're quiet, dark, and asleep. But 3Y Atlas began venting gas all the way out near Saturn's orbit, almost twice as far. Something inside it was heating up long before physics said it should. One researcher in Germany described it with a smile. It's like finding a kettle boiling before the stove is even on. It was both absurd and fascinating. Then came the metallic fingerprints. Buried within the spectrum were subtle reflections of nickel and iron, elements rarely found in the gas phase of comets. Normally, those heavy metals stay locked inside the nucleus, hidden under layers of ice and dust. They're simply too dense to escape easily. Yet here they were, glinting in the light like sparks off a blade. And the shape of the object, according to high-resolution photometry, wasn't round at all. It was elongated, roughly knife-shaped, thin and stretched, tumbling with that same unshakable 4-hour rhythm. To some, it recalled the infamous Oumuamua, the first interstellar object ever observed, long, flat, and strangely reflective. To others, it looked like coincidence wrapped in poetry. But the connection was hard to ignore. Both Oumuamua and 3I Atlas were outsiders. Both moved too fast, too precise, and too light for what they appeared to be, and both whispered in the language of metals. Still, scientists tried to stay grounded. Maybe the nickel wasn't metal at all. Maybe it came from nickel-bearing dust, or mineral grains vaporized by sunlight. Maybe the early water release was due to trapped gas pockets under pressure, bursting open. Every explanation was tested, yet none could fully fit the data. The chemical puzzle of 3Y Atlas remained unsolved. Each answer only deepened the mystery. What was it made of? And more importantly, why was it made that way? One hypothesis, bold but beautiful, began to circulate quietly in astrophysics circles. What if 3I Atlas isn't just a fragment of ice and stone, but a remnant of something crafted, something ancient, eroded by time, yet still following the principles of design? A structure that once harnessed heat, maybe for stability or power, now weathered into the guise of a comet. A machine turned to stone, drifting silently between stars. Not because anyone wanted to believe in aliens, but because the chemistry itself seemed to whisper intent. This idea, though speculative, isn't as impossible as it sounds. In 2021, the James Webb Space Telescope detected complex carbon chains on interstellar comets that looked almost synthetic, molecules with symmetry too clean for pure chance. And on Earth, our own spacecraft, when viewed from afar, might mimic comets too. Metallic surfaces glinting, gas trails venting, light curves repeating in predictable rhythm. To an alien observer, even a ship like Voyager would look more like a comet than a machine. So perhaps the question isn't, is 3I Atlas natural? But what if natural and artificial are no longer opposites, just points along the same cosmic evolution? Maybe civilizations, like stars, also shed pieces of themselves into the dark, fragments that drift for millennia, mistaken for stones. One young researcher wrote in her notebook after studying the data, "If nature wrote this chemistry, it used an alphabet we haven't learned yet." And that's the essence of 3i Atlas. Not proof, but invitation. An invitation to relearn what we think natural means. In science, humility is more powerful than certainty. Every time we think we've mapped the universe, it hands us an element we didn't know existed, not on the periodic table, but in our own understanding. 3i Atlas reminds us that discovery isn't about confirming what we expect. It's about making peace with what we don't. Today, observatories continue to watch the object. Its strange chemistry persists: nickel, CO2, cyanide, faint hints of organic dust. Each new observation adds another brushstroke to the portrait of something we can't quite name. And as data accumulates, one question keeps echoing through the halls of research centers and midnight discussions among astronomers. If this isn't nature as we know it, then whose nature is it? But before the world could settle on an answer, something else began to happen. A quiet shift, not in the sky, but here on Earth. Scientists weren't just analyzing data anymore. They were arguing about what it meant. Some saw 3i Atlas as evidence of cosmic intelligence, a messenger or artifact. Others saw only coincidence, noise dressed in mystery. The debate grew louder, crossing from labs into newsrooms, from journals into podcasts. And standing at the center of it all was a familiar name: Avi Loeb, the Harvard astrophysicist who once suggested that Oumuamua might be alien technology. The stage was set for one of the most heated scientific debates of the decade, not about the object itself, but about the limits of belief and how far we're willing to stretch the definition of science to embrace wonder. Part 6. The Silent Debate. SETI, Avi Loeb, and the Return of the Alien. Age-old question. Science has always balanced on a thin line between what we know and what we dare to wonder. For centuries, that balance has kept humanity steady. But every so often, something appears that makes the line blur. Something like 3i Atlas. When the news of its strange chemistry and perfect rhythm spread across the scientific world, it was as if the universe had dropped a riddle in our hands and quietly stepped back. And suddenly, that old question, the one we'd learned to ask only in whispers, came back with full force. Are we alone? It wasn't the first time that question had stirred the halls of academia. But this time, it carried the voice of someone who refused to stay silent: Professor Avi Loeb, a Harvard astrophysicist known for both his brilliance and his bravery in asking questions that others avoided. Back in 2017, when another mysterious traveler, Oumuamua, passed through our solar system, Loeb did something few scientists dared. He looked at the data, saw the same odd combination of light and motion that 3i Atlas now echoed, and asked, "What if this isn't a rock? What if it's technology?" The world laughed. Headlines called him the alien hunter professor. Podcasts debated him. Colleagues dismissed his theory as reckless. But Loeb didn't flinch. He said calmly, "Extraordinary claims require extraordinary evidence. But extraordinary silence also requires explanation." That silence, the refusal to even entertain the possibility, disturbed him more than ridicule ever could. And so, when Three Eye Atlas appeared, with its nickel-rich glow and double heartbeat, Loeb didn't hesitate. He recognized the melody, and he spoke again. He wrote essays, gave interviews, even hosted discussions for Project Galileo. His research initiative designed to search for evidence of extraterrestrial technology using the same telescopes that study asteroids and comets. For him, the question wasn't, is it aliens? It was, why are we so afraid to ask? SETI, the search for extraterrestrial intelligence, had been asking that question for decades. From the radio antennas of Arecibo to the massive dishes of Green Bank and Meerkat, scientists had been listening for voices in the cosmic dark. But they listened in one way, for signals, not artifacts. They searched for transmissions, not travelers. Loeb's approach was different. He wanted to look for objects, things that might move, shine, or behave unnaturally. To him, the silence of space didn't mean emptiness. It meant subtlety. Maybe we weren't supposed to hear a voice. Maybe we were supposed to notice a rhythm, but not everyone agreed. Some accused him of chasing fantasy, of feeding conspiracy culture. Others feared that even suggesting alien technology could tarnish the reputation of serious science. A few, quietly, admitted they admired his courage, but couldn't afford to say it aloud. The debate became less about the object itself and more about what science is allowed to feel. Is wonder unscientific? Is curiosity dangerous? It was a strange irony. The same species that had looked up at the stars for millennia now hesitated to admit awe. A journalist once asked Loeb if he ever got tired of the criticism. He smiled and said, "Criticism means people are listening. Indifference would mean the universe has gone quiet." It was the kind of answer that reminded people why they loved science in the first place, not because it was certain, but because it was alive. Meanwhile, telescopes across the world continued to track 3Y Atlas. The object's light pulsed steadily, its metallic chemistry unchanged. Each new dataset was another verse in the same unbroken song. And as weeks passed, the debate deepened. Some SETI researchers argued that if 3I Atlas were truly artificial, it should emit radio signals. But the sky remained silent. No pings, no whispers, no digital heartbeat, just the quiet shimmer of light. To Loeb, that wasn't proof against intelligence. He argued that if humanity had built something to drift between the stars, it wouldn't shout either. It would listen. It would watch. It would wait. And perhaps that's what this object was doing, waiting to be noticed. It's easy to forget that science and spirituality often overlap, not in their answers, but in their humility. Both ask us to look beyond ourselves. Both begin with the same act, wonder. As the 3I Atlas debate grew, something subtle began to change in public tone. For the first time in years, the alien question didn't feel childish. It felt mature, quiet, thoughtful, possible. People weren't shouting for proof, they were whispering for meaning. Sometimes the hardest part of discovery isn't finding the evidence, it's allowing yourself to believe that you might. Skepticism protects us from error, but courage protects us from silence. 3I Atlas reminds us that both belong in the same room, and perhaps that's the beauty of this debate, that it's silent, No one's shouting, no one's claiming victory, just questions floating like dust in the air, waiting for light to touch them. Because in the end, science isn't about winning arguments. It's about expanding the space where questions can live. Months later, as the object approached its closest point to the sun, a new round of data arrived, and with it, something unexpected. The brightness didn't behave as predicted. It flickered, then steadied, then flickered again. It was subtle, almost like a breathing pattern. And when researchers cross-referenced it with older data, they realized something extraordinary. The timing of those flickers matched the 4-hour and 2-hour rhythm, but with a new twist. The ratio was shifting, the beat was accelerating. Whatever 3-Eye Atlas was, it wasn't static, it was changing, and that changed everything. Part 7, The Skeptic's Mirror. Could it all be a trick of the data? In every great mystery, there comes a moment when wonder meets resistance. Not from the universe, but from us. Because for every light that inspires belief, there's a shadow that whispers, "Be careful." 3-Eye Atlas had already sparked awe, curiosity, even hope. But science at its heart is not about hope, it's about proof. And proof demands doubt. When the rhythmic pulses of 3-Eye Atlas first appeared in telescope data, the world saw precision, a cosmic heartbeat too perfect to be natural. But for skeptics, perfection wasn't beauty. It was suspicious. Data, after all, is fragile. It's shaped by instruments, timing, software, even the human hands that interpret it. And in the vastness of astronomy, where we chase specks of light across billions of miles, illusion is always a possibility. One scientist from Caltech put it simply: if you stare at noise long enough, it starts to hum a melody. So the skeptics began their work, quietly, methodically, without malice. Not to destroy wonder, but to test if it could stand. Because true discovery must survive fire. Their first question was one of timing. Could the dual rhythm be the result of aliasing, a kind of echo that happens when observations are taken at uneven intervals? Telescopes on Earth don't observe continuously. They take snapshots separated by hours or days. If those gaps align just right, a random fluctuation can appear rhythmic, like flickering lights that seem to sync to a beat, though they never truly do. They ran simulations. They randomized the gaps, adjusted for atmospheric interference, compared with other data sets. But the pattern stayed, so they dug deeper. Next came the cadence effect, the heartbeat of the telescope itself. Every camera has a rhythm, every detector a pulse. Sometimes, the machine sings louder than the stars. Could the 4-hour and 2-hour signatures be reflections of the equipment's internal timing? It had happened before. In 1998, astronomers studying a pulsating star thought they'd discovered a planet orbiting it every 2.6 days. Years later, they realized the planet was the fault of a software correction error, a timing misalignment in the telescope's sensor clock. The signal was real, but its source was us. So the skeptics of 3-Eye Atlas checked every possibility. They cross-verified instruments from Hawaii, Chile, South Africa, Spain. Different telescopes, different detectors, different nights. The rhythm remained. If this was an illusion, it was a remarkably consistent one. And yet, consistency doesn't equal truth. Even the most disciplined data can hide traps. What if the pattern wasn't in the object, but in our expectation? The human mind is a pattern-making machine. We find faces in clouds, meaning in coincidences, rhythm in randomness. We crave order because chaos frightens us. Perhaps, the skeptic said, 3i Atlas is only a mirror, reflecting not design, but our own need to see design. That thought lingered, not because it dismissed the mystery, but because it deepened it. What if the most intelligent thing about this discovery wasn't the object, but us looking at it? History offers many such mirrors. In 1967, a young graduate student named Jocelyn Bell Burnell detected a strange, repeating radio signal in her data. A pulse every 1.3 seconds, steady as a metronome. She and her advisor, half joking, labeled it LGM-1, Little Green Men. The press loved it. But later, they discovered it wasn't aliens at all. It was the first pulsar, a rapidly spinning neutron star, a dead sun still singing in light. The discovery didn't make her foolish, it made her legendary. Because she wasn't wrong to wonder, she was brave enough to question. That's the spirit of skepticism at its best. Not to silence curiosity, but to refine it. Still, 3i Atlas refused to dissolve into a simple explanation. The data survived every correction, every recalibration. The metallic spectrum remained. The pulse endured. But so did the doubt. Science thrives in that tension between belief and disbelief, awe and caution. It's a dialogue, not a war. As one astronomer said during a panel discussion, if 3i Atlas turns out to be natural, it will still be the most elegant accident in history. And if it isn't, then we've already met intelligence by behaving intelligently. That statement drew applause. Not because it answered the question, but because it honored both sides of the mirror. Skepticism is not the opposite of faith. It's the compass that keeps faith from getting lost. In a universe so vast, belief without doubt can blind us. But doubt without wonder can make us forget why we look up at all. The balance, that quiet dance between trust and testing, is what keeps humanity moving forward. So could it all be a trick of the data? Maybe. Or maybe it's a trick of perception. The universe reminding us that truth is rarely singular. Sometimes it's not about being right, it's about being awake. And for all their disagreements, skeptics and believers share that one thing. They're still looking, still listening, still paying attention to a faint rhythm that shouldn't exist, and yet, somehow, does. As winter turned to spring, 3i Atlas drew closer to the sun. Its light grew stronger, but its mystery only deepened. The rhythmic flashes began to change, slower at first, then faster, then something else entirely. A distortion in its pulse, as if the beat itself were evolving. Was it breaking apart? Or was it revealing a deeper pattern hidden beneath the first? To find out, scientists did what they always do when faced with the unexplainable. They stopped guessing and started building. Part 8. Reverse engineering the visitor, if it were a machine. There's a certain quiet bravery in asking, what if? It's the same question that made the first human light a fire. The same question that sent rockets into the sky. It doesn't always lead to truth, but it always leads forward. So when scientists began to whisper, what if 3i Atlas isn't a comet at all. They weren't betraying reason. They were honoring curiosity. If this traveler were a machine, an artifact from somewhere beyond, what would it need to be? How would something survive billions of miles of radiation, time, and gravity? What kind of engineering could last across eternity? It begins, perhaps, with its shape. Observations suggest that 3Y Atlas isn't round, but elongated, a thin, knife-shaped body that turns gracefully every 4 hours. That's a curious form for a comet, but a logical one for a spacecraft. A long, narrow frame reduces tumbling, allowing steady rotation. That spin, in turn, could stabilize internal components, much like a gyroscope or reaction wheel in modern satellites. It's a design principle we know well, because we use it ourselves. The 2-hour pulse of light, that secondary rhythm, could be more than reflection. It could be a modulation, a synchronization signal, or a beacon designed to recalibrate orientation using the sun's rays as reference. In human terms, it would be like a heartbeat that doubles as navigation. And yet, the idea of a machine that behaves like a comet isn't new. In 1977, when the Voyager probes left Earth, NASA engineers added small gas thrusters to adjust their spin and trajectory, the same physics we now see echoed in 3E Atlas. Even more interesting, Voyager's radio isotope thermoelectric generators, tiny nuclear batteries, still emit faint heat signatures detectable across the solar system. If an alien civilization saw Voyager from afar, they might interpret it as a living comet too, a metallic traveler venting invisible gas, glinting softly in sunlight. So maybe 3I Atlas isn't defying nature, maybe it's imitating it, using the appearance of a comet as camouflage. A machine disguised as a ghost. But if that were true, it would raise a deeper question. Who built it? And why send it here, to us, now? Some imagine it as a probe, a silent observer. A device built long ago, set adrift to study other stars, much like humanity dreams of doing with Breakthrough Starshot, our plan to send microprobes to Alpha Centauri. It could be a relic, drifting endlessly, its mission forgotten, its creators long gone. Others picture something more profound, a cosmic seed, carrying encoded data, maybe even genetic blueprints, a whisper from civilization to civilization. But whatever its purpose, one truth would remain. It would be ancient, older than any human memory. Older, perhaps, than our species itself. Of course, not all who pondered this idea were dreamers. Some were engineers, practical minds who tried to model what such a craft would need to survive. To resist solar radiation, it might use a layered nickel-iron composite, the same materials found in the object's spectral fingerprint. To maintain its rhythm, it could have a central core of magnetic stabilizers, now long dormant, but still functional through residual momentum. And its outer crust, covered in dust and ice from eons of drifting, could perfectly mimic the look of a comet's surface. Even its early breathing, the premature venting of water vapor near Saturn's orbit, might not be venting at all. It could be thermal regulation, the slow release of trapped gases to prevent structural stress. In short, every mystery might also be a mechanism. And isn't that, in a way, what technology is: the poetry of purpose hidden in plain sight. Still, no one claims certainty. This isn't proof, it's perspective. It's humanity doing what we've always done, holding a mirror up to the unknown and seeing fragments of ourselves. Because to reverse engineer something you don't understand isn't about taking it apart. It's about learning from its silence. It's about imagining the hands, or the minds, that might have built it. When we study Three-Eye Atlas as though it were a machine, we're really studying ourselves, our yearning to create, to endure, to leave a mark that survives the dark. A philosopher once said, "Perhaps all of civilization is just the universe trying to understand itself through us." If that's true, then maybe Three-Eye Atlas isn't an intruder, but a reflection, a reminder that creation is not the privilege of one world, but the instinct of life itself. Across galaxies, the same impulse might exist: to build something that outlives its makers, to send a message across the deep, even if that message is only, "We were here." When we wonder if something was built, what we're really asking is whether meaning can survive time. Because deep down, that's what every human creation hopes for, not immortality of the body, but of the idea. And maybe, in that sense, Three-Eye Atlas and Voyager are siblings, two silent travelers from different corners of the cosmos, passing each other in the night, each carrying proof that curiosity endures. As the debate about Three-Eye Atlas's true nature continued, new eyes joined the search, not from Earth this time, but from Mars. During one quiet evening on the Red Planet, the ESA's Mars Express orbiter captured faint glimmers in the sky, tiny pulses near the trajectory of Three-Eye Atlas. They were subtle, almost imperceptible, but they matched the object's rhythm. For the first time, we were seeing it not just from below, but from the side. A new perspective, one that could confirm or undo everything we thought we knew. The universe, it seemed, wasn't done speaking, and its next whisper would come from a world we've only just begun to call home. Part 9. The Red Planet. Witness shall Mars the shutdown and the silence of Earth. Sometimes, when one world falls silent, another begins to speak. And so it was with Mars. While debates on Earth turned to politics and pride, the Red Planet simply watched. From its thin skies through its drifting dust, Mars had the best seat in the solar system, a quiet witness to the passing of Three-Eye Atlas. It was late October, when the object drew closest to Mars, a brief encounter written in orbital geometry, predicted months before, but anticipated by few. The ESA's Mars Express orbiter, an aging yet faithful spacecraft, was in the right place at the right time. Its instruments, designed to study Martian clouds and auroras, suddenly found themselves staring into the deep, catching faint glimmers against the black. At first, no one expected much. Mars Express wasn't built for interstellar observation. But what it captured that night was peculiar. Tiny pulses of light barely above the noise threshold, yet perfectly timed, 4 hours apart, then 2. The same rhythm, the same impossible song. Down on Earth, however, there was silence. Because at that very moment, NASA's data channels were frozen. A government shutdown had halted all public updates, locked communication lines, and delayed the release of any new astronomical findings. It was a strange irony. Earth, our vibrant, noisy planet, had gone quiet, while a cold, empty world, 225 million kilometers away, became the only one still watching. For weeks, that silence felt heavy. It wasn't the silence of space. It was the silence of bureaucracy, of waiting rooms and unanswered emails. The silence that happens when curiosity meets the wall of procedure. And yet, in that pause, something beautiful occurred. Scientists from other nations, France, Japan, India, Chile, and Russia, stepped in to share data, relay messages, and keep the rhythm alive. Without fanfare, humanity acted as one, as if the stars had reminded us that discovery doesn't belong to a single flag. When NASA finally resumed operations, the backlog of signals began to pour in. Buried within those files was confirmation. Mars Express had indeed captured something real. Faint, but unmistakable. The pulse of 3I Atlas, echoing from beyond the orbit of Mars, steady, serene, deliberate. No one knew what it meant. Was it reflection? Was it coincidence? Or was it, as one European astronomer quietly suggested, a gesture, the cosmos reminding us that while we argue, it continues to speak? To understand how rare that alignment was, imagine this: two worlds, Earth and Mars, both turning in their orbits, one covered in oceans, the other in dust, and between them, a single point of light that bridges the silence of both. That's what happened in those weeks. A moment of cosmic symmetry, a whisper caught between two planets. And yet, when the data finally became public, the world barely noticed. Headlines were filled with elections, conflicts, new technologies, celebrity scandals. The story of a light near Mars, beautiful, patient, unsolved, wasn't loud enough for a world addicted to noise. But perhaps that's what made it sacred. Some truths are too gentle for the news cycle. They ask not for attention, but for stillness. One of the engineers who worked on Mars Express later wrote in her journal, "I watched that light cross our instruments like a heartbeat from another century. It didn't care about our shutdowns, our budgets, or our fears. It just kept shining." It's a reminder that the universe doesn't pause when we do. It doesn't wait for us to be ready. It moves in its own time, in its own rhythm, and invites us to catch up. Sometimes silence is not absence. It's an invitation to listen differently. When things stop, when data freezes, when the world seems quiet, that's often when the universe whispers the loudest. We spend so much of our lives trying to fill the quiet. But maybe, like Mars that night, we were meant to observe, not interrupt. By the time Earth's observatories turned their gaze back toward 3Y Atlas, the object had already begun its retreat. Its light softened, its pulse stretched. From the vantage point of Mars, it was already fading into the sun's glare, a silver ember swallowed by gold. And yet, as it disappeared, the data from Mars revealed one last, haunting detail. In the final hours before it vanished, the 2-hour pulse began to blur into one. Not stronger, not weaker, just unified. As if, in its final act, the visitor had merged its dual rhythm into a single, calm note. No scientist could explain it. No equation could describe it cleanly. But to those who watched, it felt like closure, a farewell not in words, but in light. Maybe that's how the universe says goodbye. Not through endings, but through harmonies that resolve themselves. The way a song finishes not with a crash, but with a final, gentle chord. 3i Atlas came to us as a question, a rhythm, a reflection, a mirror, and as it left us with what all great mysteries leave behind. Not certainty, but gratitude. Gratitude that we were here to witness it. That for one brief moment, two planets shared a heartbeat. That silence, after all, was never empty. As the light faded beyond Mars, a quiet realization settled over the world of science. That maybe the real discovery wasn't the object at all, but the way we changed while looking at it. The way we learned to cooperate, to listen, to hold space for wonder without rushing to own it. Because sometimes the point of the mystery is not to solve it, but to remember what it feels like to be curious.